We are live. Hi everyone, welcome back to Codera. Today in this video, we'll be discussing the Leetcode daily challenge for 19th of January. The name of the problem is linked list cycle 2. This problem has been previously asked in organizations like LinkedIn, and it has also been asked in Microsoft, right? As you know, these companies ask questions based on linked list a lot, right? So quickly give me a +1 in the chat if my voice is audible to everyone and my screen is also clearly visible, and then we will start with the discussion of this problem. This problem is rated as medium, and for someone who knows how to find a linked list in a cycle, how to find a cycle in a linked list, he or she can do this question very easily, because in this question you just have to return the starting node of the cycle of the linked list. Okay, you have to return the node where the linked list cycle is starting. So all of you, please consider giving me a quick +1 in the chat, and then we'll start with the question. Okay, is everything working fine? Just let me know. Okay, right. So this particular question, as I said, this is nothing but named as linked list cycle 2. Okay, this is nothing but linked list cycle 2, although it's rated as a medium level problem, but if you have done it once or if you just try it, so it will seem easy medium level. Okay, it's not actually a medium level problem, right? So in this part, I'll just wait for a couple of minutes more for everyone else to join, and then we'll start. Okay, right. So what you have to do in this problem is you will be given a linked list. Let's say you have been given a linked list like this: 1, then 2, then 3, 3 to 4, 4 to 5, 5 to 6, and then you have been given 6 is connected to 3, right? So does there exist a cycle in this particular linked list or not? Yes, there exists a cycle, right? If a cycle is existing, the normal linked list question was that if a cycle is existing, then you have to return that true if the cycle exists, if you have to return false if a cycle does not exist. But in this question, what you have to do is you have to return the starting node. You have to return the starting node of the cycle. Okay, this is what you have to do, right? This question has been asked multiple number of times in companies like Microsoft. It has also been asked in LinkedIn. Okay, it has also been asked in LinkedIn, and this has also been asked in Amazon, but more frequently it has been asked in Microsoft and LinkedIn. Okay, so is this problem clear to everyone? Quickly give me a +1 in the chat if this problem is clear to everyone, right? So now talking about this problem, right? So in this problem, as you know that in this problem what you have to do is basically you have been given the head of the linked list. Okay, and you have to return the node where the cycle is beginning. Okay, if there is a cycle, then you have to return the node where the cycle is beginning. Otherwise, if there is nothing like that, so you have to return null. So there is a cycle in a linked list if there is some node in that list that can be reached, hi Aryan, can be reached again by continuously following the next pointer. Okay, like this you can see there is a cycle when you can move from 2 to 0, then 2 minus 4, and then you move to 2 again. So this is a cycle, and the starting point of this cycle is 2, right? So if a cycle does not exist, so you have to return null. And in this particular problem, let's say you have been given the sample test case like this. Let's say you have been given a sample test case like this. Let's say you have been given 1, then you have been given 2, then you have been given 3, then you have been given 4, and then let's say you have been given 5 after that, and then the 5 is connected to 2, like this. So can someone tell me in the chat that for this particular question, what is the starting point of the cycle? What is the starting point of the cycle for this particular question? Hi Pranay. Okay, so starting point of the cycle, our cycle starts at the node 2. Okay, it starts at the node 2. So there are basically two approaches with which we can do this question. First of all, how do you see that you have, whether you have a particular node that you are occurring at the again? Okay, you are going to again. So if you see you are at the node 1, then from that you move to node 2, so you say okay, then you move to node 3. Okay, have you seen these nodes earlier? Once you move to node 1, have you seen it earlier? No. Once you move to node 2, have you seen it earlier? No. Once you move to node 3, have you seen it earlier? No. Once you move to node number 4, node value 4, have you seen this earlier? No. Once you move to node number 5, have you seen this earlier? No. But once you move to node number 2, then what happens? You can see that you will be able to observe that you have already seen this particular node. Okay, you have already traversed this particular node, right? If this much part is clear, so please give me a +1 in the chat, right? Everyone consider giving me a quick +1 in the chat if this much part is clear, right? Okay, so now what you have to do is you can do a hash map kind of approach. Okay, you can do a hash map kind of approach, and in that approach what you would be doing basically is you would be marking a pointer as current pointer, and right, so you make a hash map, let me write it again. Okay, so you make a hash map, let's say something like this. You make a hash map. Okay, you make a hash map in which you will be storing the node. If a node is present, so you will mark it as true or you will mark it as 1, indicating that it's present. Let's say you are traversing for 1, 2, 3, 4, then 5, and 5 is connected to 2, like this. Okay, so in this particular question, what you will do, you will apply the concept of hashing. How will you apply the concept of hashing? What you will be doing is, first of all, you move to this particular node. So you'll be making a map of the node, right? Comma, let's say int. Okay, or you can make instead of using this int, you can use bool. So basically you'll say that 1, for 1 I'll mark it as true, let's say true or 1, okay, indicating that it's present. So for 2 I'll mark it as 1 as well. Okay, I mark it as 1 as well. For 3 I'll mark it as 1 as well. The current node would be 3, I mark it as 1. Then for this particular node 4, I'll mark it as 1, indicating that okay, I have traversed it. Then for 5 I will mark it as 1, that saying that okay, I have traversed it. Notice that these nodes hadn't been seen earlier in the map, right? But when my current moves particular node, so I can see that it is already existing in the map. My 2 is already marked, so that means I have already traversed 2. So that is why I'll say that there is existing a cycle, and the starting point of the cycle will be the current node, right? The first node which is repeating, which I am repeating will be the starting. If this much part is clear, please write clear or a +1 in the chat, and then I'll move to the more optimal approach. For this particular approach of using a hash map, the time complexity would be order of n, and the space complexity would be order of n as well, right? If this much part is clear to everyone, please consider giving a quick +1 in the chat, and then we'll proceed further, right? Shall we proceed further? Okay, so now let's move ahead with this particular question. So what you could do is you can use the Floyd cycle detection method, right? What it is actually, I'll be telling you. Let's say there is a linked list like this. Okay, if there is a linked list like this, so I can have 2 pointers. Okay, I can have 2 pointers, and in that what you can have is I can have a slow pointer which moves by 1, and I can have a fast pointer which moves, this slow pointer moves by 1. Okay, a distance of 1 by 1 node. This fast pointer moves by 2 nodes. Okay, right? So this is what it does. So now in this particular thing, what you will observe is that if I have one pointer, if I have one of the pointers which is moving fast, if one pointer is moving at a speed of, let's say, x times, right? If let's say the slow pointer is moving at the speed of x kilometers per hour, right, and the fast pointer is moving at the speed of 2x kilometer per hour, so who will end up the traversal very first? Who will end the traversal first? I can say that fast will reach the end. Okay, fast will reach the end, right? What will happen? Let's say fast is I make slow and fast pointers. Okay, I have this slow and fast pointers. What I could do is initially both of them will be at 1. Now my slow moves by 1, so slow moves to 2, fast moves to 3, then my slow moves to 3, right? It moves by 1, and fast moves to 5, like this. Okay, then at the moment when my slow moves to 4, my fast would be moving to null, right, at the end of the linked list. So you can see if slow is moving by x speed, so fast is moving by 2x speed. So if there is no cycle in the linked list, then fast would reach to null, and there will be no time, there will be no opportunity such that the value of slow pointer and the fast pointer would be the same, right? This is one thing that we can observe from this particular test case. Now, when will slow and fast data not be the same? They will never be the same, because one is the fast pointer is moving by 2 times the speed of the slow pointer, right? So in that case, there is no chance that they will be meeting at a particular point. So this will indicate that if the fast pointer reaches the end, so it will simply indicate that there is no cycle. But what if slow and fast have the same value at a particular point of time? If my slow and fast pointer have the same value, in that case what does it indicate? That although my fast pointer is moving twice the speed of slow pointer compared to slow pointer, but still fast and slow are having the same values at a particular point of time. So that means that there must be existing some cycle because of which this will happen, right? If this part is clear, so please consider giving a quick +1 right in the chat, or write clear in the chat, and then we'll proceed further. Okay, so the thing is that this much part would be clear, right? So I have, let's say, 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5, and then 5 is, let's say, connected to 2, like this. Okay, thanks a lot, Aryan. Okay, so let's say I have a slow pointer and I have a fast pointer, right, like this. So I'll have, basically we are trying to build the intuition, like how will you actually develop the approach, and we are trying to see why fast and slow pointer will not meet when there is will not have the same values when you will when there is no cycle, and why they will have the same value when there is a cycle. Because if the fast is moving twice the speed of the slow pointer, in that case the fast and slow pointer should not have the same value. If they have the same value, so that will indicate that my fast and slow are having the same value, so it means that there is a cycle, right? So my slow will be 1, my fast will be 1, so my slow moves by 1, so it moves to 2, fast moves by 2 the double the speed, so it will be pointing to 3, then slow is 3 and fast will be 5, then my slow will be 4, and what will be the value for my fast? My fast will be what? My fast would become I am at this 5, so I'll become 3. Okay, after that what would happen? After that simply you can say that my slow moves to 5 and my fast moves to 5 as well, right? This will be the particular situation, right? So in this particular case you can see that my slow and fast are coming same. So this indicates that I have a cycle. This is but nothing but the Floyd cycle detection algorithm that we used in a linked list, right? This is nothing but the cycle detection algorithm that we regularly keep on using. Now the thing is that for this particular program, for this particular linked list, is this 5 my starting point of the my starting point? No, it's not. So what I would be doing is I would say that okay, my fast is pointing to 5 currently. Okay, I'll say that okay, my fast is pointing to 5, and let's mark my slow to the starting. Okay, so fast will be here, fast will point here, and my slow would be here, right? So I'll move both of them by 1. So if everyone is clear with it, so please like the video and please consider giving me a +1 in the chat if everyone is clear with the explanation part. Okay, right? So now what will happen? My fast is at 5 and slow is at 1, so now all of them will be moving by 1. Okay, so my slow moves to 2. Okay, my slow moves to 2, it moves by 1, so it moves to 2, and fast also moves by 1. So from fast is currently at 5, so 5 moves by 1 node, so it reaches 2, right? So you can see that whenever after you have marked your slow towards the head, and after that whenever my fast and slow they will be moving by 1, and whenever they are equal, so that will be the starting point of the linked list. Let's take a bigger sample test case for example. So let's say if I have 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5, 5 to 6, and 6 to 7, and then let's say 7 is connected to 3, something like this. Okay, so for this particular linked list, can someone tell me in the chat what is the cycle that I am having, or what is the starting point of the cycle? Am I having a cycle or not? Yes, I am having a cycle, right? So initially I'll say that my fast is pointing to 1 and my slow is also pointing to 1. So my slow moves by 1, so it moves to 2, and my fast moves to 3. After that my slow moves to 3, so it moves by 1, and my fast moves by 2, so it moves to 5. After that my slow moves to 5, and my not 5, slow moves to 4. Okay, and my fast moves where? My fast moves to 7 because it is taking jumps of 2. After that my slow moves to 5. Where does my fast move to? My fast moves to 4, right? After that my slow moves to 6, and my fast also moves to 6, right? So can you observe something? Hi Aman. Okay, can you observe something in this particular question? in this particular question, you can see that now my slow and fast are again the same. See, slow is taking jumps of 2, slow is taking jumps of taking jumps of 1, and fast is taking jumps of 2, right, from 1 to 5 to 7 to 4 to 6, right, like this. So you can see that slow and fast meet at this particular point 6. So is this the starting point of the cycle? No, it's not. Right, so it is just helping us to find that there is a cycle. Now the thing is that how will you find furthermore? So what you will be doing is, you mark your slow to the head, you point your slow to the head. Okay, you say that slow is nothing but head, you point your slow to head. So now let's say slow is equal to 1, and keep your fast at the same point. So fast will be at 6. Now you move both of them by 1. Now you move slow by 1 as well and fast by 1 as well. So you move slow by 1, so slow moves to 2, fast moves to 7. Then you move slow by 1, so it moves to slow moves to 3, and fast moves to what? Fast moves from 7 to 3. So you can you observe something? What is the special thing about 3? 3 is nothing but the starting point. 3 is nothing but the starting point of the loop. Okay, starting point of the loop. And if it happened that my slow and fast were never the same, in that case I would, if these were never the same, then in that case I would have returned a null, right? Is this much part clear to everybody? Is this much part clear to everyone? Then we'll proceed further. Okay, let's proceed further in this question. So for this particular approach, I would say that the time complexity for this particular approach would be order of n. Okay, and the hi Shreya Singh, is the question clear to you? And the space complexity for this question would be order of 1, because I'm just using the fast and the slow pointer, and not using any extra array, I'm not making any linked list, I'm not using any other data structure, right? So this was the approach. So I'll show you the code part for this particular approach, what I have done basically. So this is the code. What I'll be doing is, I'll be marking my slow towards the slow at the head, fast at the head. I'll move until my fast, like this much part you can also remove. Okay, I'll move my fast until fast is not equal to null, or fast next is not equal to null. Okay, so either my fast can become null, or my fast next can become null. So whenever any one of them becomes null, so I'll break at that particular position, because indicating that I've reached the end of the linked list. Okay. After that, what would I do? I'll mark my slow is equal to slow dot next. So I'll move my slow by 1, and I'll say fast is equal to fast dot next. So I'll move my fast by 2 nodes. Okay. If my slow and fast are the same, if slow equal fast, so that means that both of them are having what? Both of them are like this particular linked list will have a cycle. Otherwise, if someone is moving twice the speed of the other person, then there is no chance for them to meet. But if the slow and the fast pointer are meeting, so that simply indicates me that I have this cycle thing, right? Only then they will be moving. So only then they will be meeting, right? So there will be existing a cycle. So I mark my slow is equal to head, indicating that slow is moving to the start, and until the time my slow is not equal to fast, I'll be moving slow by 1 and fast by 1, and in the end I'll simply return my slow. Now there would be a situation such that, suppose that there was no loop existing, right? If there existed no loop, in that case I would simply return a null. Why would I simply return a null? Because they will not be existing any cycle, right? So for the first, we discussed 2 approaches for this particular problem. The approach number 1, we use the concept of hashing, right? We use the concept of hashing to find the cycle, and the node and the starting node. Okay. And in approach number 2, we use the concept of what? Cycle detection algorithm, or you can say 2 pointers, right? If this much part is clear to everyone, please consider giving a like to the video, and please give me a +1 in the chat. Okay, we use the concept of 2 pointers, where we had one slow pointer and another pointer as fast pointer, right? And what we did was, we tried to see if they are meeting. So that means there would be existing a cycle. Otherwise, if someone is moving twice the speed of the other person, so there is no chance that they should meet, right? So this was the code, and this was the approach for today. So this was the problem of this was the Leetcode daily challenge for today, for 19th of January. That was linked list cycle 2. So you can consider liking the video. Also, once you have submitted the code for this particular problem, so come back to this video and write down in the comments that I have submitted the Leetcode daily challenge for today. So this will keep you going, and this will I'll provide the code link in the description of this video. And also make sure to check out our channel, that is Code Era, because on this channel we have been doing a lot of live streams, and we have been doing a lot of content based on competitive programming. That like said, for tomorrow I'll be taking the Mastering Codeforces session 3, so you can attend that as well. Apart from this, I am doing Leetcode daily challenges every day, so you can also follow the channel